Daniel, you made my day today. Thanks for picking up Eric's phone call. He says you normally deny him phone privileges, so I appreciate that. All right, so we're going to go over homework now, and you guys don't know how to do number 9, which means you do not know how to integrate ln of x over x is kind of what I'm thinking, okay? You guys figured out that the pattern was ln of x over x, so that's good. Couple ways to do this one. You can do it 2 ways. What are some of the tests that I've taught you? Divergence test, okay? So let's just try that out. Divergence test. I want to see what the last guy goes to, okay? If it goes to not a 0, what happens? Blows up, boom, diverge, done. That's what I'm hoping for. All right, this is infinity over infinity. I don't know what that means, so I'm going to do hope etal. And I get, let's see, 1 over x over 1, which goes to 0. So what does that mean? Has a chance. I have a chance to converge. Doesn't mean I'm going to, but I have a chance. Okay? So did the divergence test really help me? No. Because the divergence test only helps you if it diverges. Okay, so then the one I taught you yesterday was the integral test. So I'm going to integrate from 2 to infinity of ln of x over x dx. And I'm going to hope I get that to converge. If it converges, my series converges. What do I need for the properties to do the integral test? 3 things. What did I need? Let me think for a second. Is x all positives? Because it's 2 to infinity. Where is ln above 0? At what's this? At 1. So good. Positive. Continuous? Need continuous? Continuous. It is, because where is the only issue? At 0, and I'm integrating from 2 to infinity, so I'm good. What was the other one? Got a decrease. Could you graph that and take a look? Okay, it does. Cool. Decrease. Okay, so now I got to integrate. Integrate. It's a U sub. It's a normal U sub. You guys never see this one. And I don't know why you don't see this one. You guys are so used to like this being the very basic U subs, like x to the 4th plus x to the 5th. And you have 4x cubed plus 1 out there. And you see it very nicely on those. But you, for some reason, never see the U sub here. When U is ln of x, what's the derivative of ln of x? 1 over x. So I have that. You might see it better if you want. You could write it this way. This might help you. Is that the same problem? Do you see the U sub a lot cleaner now? It's almost like you don't see it because you're expecting a 1 over x, and that 1 gets hidden because the x just slides into the bottom. It's a perfect U sub. So this is a perfect U sub. So with that perfect U sub, with u being ln of x, everything works out. So this is the integral of u du, which goes to 1/2 u squared, which is 1/2 ln of x squared from 2 to infinity. Uh-oh. What happens? Diverges, because this blows up. So the integral diverges. So the series diverges by the integral test. Okay? The biggest thing is you don't see that U sub. Okay? That's what your guys' issue is. That's a Calc 1 question. I'm not mad at you. It's a classic integral that a lot of people don't see the U sub working. Better on that one? Okay? Others? Yep. 79, 79, 79, 79, 79. Cool. 79. Next page. Next page. Think about it. Do it. There you go. 79. N equals 1 to infinity. 1 plus 1 over n to the n. It is. I hope so. Daniel, are you hearing me? Yes, you are. We're at 5 minutes 26 seconds. Good luck on your game today. Okay. Okay. So, what test should you maybe do first? Divergence test. Yeah. So I'm looking at just the last guy. Where does he go? That would be 1 to the infinity, right? The 1 over n goes to 0. Infinity, is that indeterminate? Okay. Indeterminate. So we're going to do hop. But should I do the hop yet? Log it first. So if I'm going to go into the log world, I got n ln of 1 plus 1 over n. You guys okay with that? Because that n falls down when you take the log. Then I would go with ln of 1 plus 1 over n all over 1 over n. Let's check now what happens. ln of 1 is 1 over infinity. Still Hopi-Tallet. So then I get, let's see, 1 plus 1 over n. And what's the derivative of the inside? I get a 1 over n squared. All over the same negative 1 over n squared. This looks super ugly, but do you agree those 1 over n squareds should cancel out? So this is really just 1 over 1 plus 1 over n. Okay, because these guys canceled out. Plug in infinity there, and I get 1. Okay, now that's in the ln world. So to get out of the ln world, I need to it. So the original guy was 1 plus 1 over n to the n, and I was asking us, what does that guy go to? He goes to e. And so diverges by divergence test. Because it doesn't go to 0. If it goes to 0, it has a chance. Then you got to go do something else, like hopefully try and do the integral test. But this one, right away, the last term goes to e, so it doesn't go to 0, so it blows up. Okay. This is a typical. This could be like a multiple choice question on AP, and you could do none of the work and just say it goes to E. Start knowing that one, okay? That one's a one that it's nice to know because it voids all of the calc work, and then you just see this and go, oh, that's the formula for E, basically. Okay? Is okay with that? Cool. Others? Yep. 68. 68. Okay. And I gave you guys a hint on this one that this is a telescoper. Okay. And you might not see the telescope right away. Okay. This is a big-time hidden telescope. If I just want to write some of these out, let's see what I get. Let me do this first just so you might be able to plug in a little bit quicker. Is this the same? I just simplified. I got common denominators. I just did that, so it's going to be a lot quicker for me to get my guys here. So let's see. When I do that, plug in 2, I'm going to get ln of 3/4 plus ln of 8/9 plus ln of 15/16 plus ln of 24 25ths plus ln of 35 36. Okay? I don't see telescoping yet, because telescoping you should be expecting a plus and a minus, a plus and a minus, a plus and a minus. What can you do with ln's of fractions on the inside? Split them up. So then this could be written as ln of 3 minus ln of 4 plus ln of 8 minus ln of 9 plus ln of 15 minus ln of 16. But this is weird, because now it's looking like a telescope, but are things canceling? No, they're not canceling out. Okay? So there's an issue there, and you're like, no, don't believe it, don't see it, I don't see it. You guys agree? Okay? There's two ways to do this. Okay, I'm going to actually go a different way. You can simplify these like ln of 8. What could you think of him as? 4 over 2? Yeah, could this guy here be ln of 4 times 2? Could then that be like ln of 4 plus ln of 2? Does that ln of 4 cancel with the other ln of 4? You guys see that? Okay. So do you agree that could I break ln of 9 up? Could that be ln of 3 and a 3 and a 3? Would one of the ln of 3's cancel then? Do you guys see how you could break a lot of them up? But instead of trying to decide how I want to break things up, how could the 16 go? Lots of options. 4, 4, or 2, 8, that idea. So instead of you deciding how to simplify them, let me ask you here. Could I have done this guy one more step? How's the top factor? N plus 1, N minus 1? You guys agree with that? Could then this be, could I do all of these where these are ln, I'm running out of space. I'll go down here with it now. Stare at the purple guy, and could that purple guy then become ln of n plus 1 plus ln of n minus 1 minus ln of n squared? What can the 2 happen with the n squared? 2 ln of n? Is that the same? So n plus 1, n minus 1, those add, minus 2 ln's of n. Is this as far down as you can possibly go on the breaking up of things? Why I'm doing it that way is instead of having a choice with ln of 16 and how do you want to break it up, have I already broken up the basic the whole way through? Okay? So now, let's see what we get. So with this guy, I would have ln of 3 plus ln of 1 minus 2 ln's of 2 plus, I'll just do it right below it. The next guy would be ln of 4 plus ln of 2 minus 2 ln's of 3. You guys agree with that? And ln of 5 plus ln of 3 minus 2 ln's of 4. I'm just going to write another one. ln of 6 plus ln of 4 minus 2 ln's of 5's. Guys okay with that? And could I keep going forever? Okay, there's some that add up. There's some that subtract. When you see this ln of 4, I'm going to do some highlights. One ln of 4, another ln of 4. Will there be any more adding up of ln's of 4, or have I already kind of passed through that number? So I have 2 of those guys, but what do I get to do? Subtract them. So do I have any ln of 4's? Nope. I'm going to have a ln of 3 and an ln of 3. Have I passed through those ln of 3's? But I get to cancel those out. Guys agree with that? Do you agree that I will have an ln of 5 here, an ln of 5 here, and it should cancel out? Will from 3 on, will I always cancel out? Because you're always going to get, do you agree? 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many are you always going to get of all of the numbers from 3 and above? 2. And what are you always going to have? Minus 2 of them. So the only piece that doesn't cancel out is that piece. So let's look what that is. I got ln of 1 minus 2 of them plus 1 of them, so minus ln of 2. Guys agree with that? What's ln of 1? So I'm left with, okay, this would have been like a challenge set problem for me. Okay, what's up? So the last guy always let me think for a second. Oh. Oh, yeah. Cool. Yeah. Good. Okay, good point. You're right. Normally, telescoping means you take the first couple guys and then you add in the last guy. Thanks. Who's the last guy if you plug in infinity here? 1. Because in this case here, when you look at this last guy, when you look at the very last guy of the thing, since these degrees are the same, you can look at the coefficient in front, so it's going to be ln of 1. So the ln of 1 is the very last guy, and ln of 1 is 0. So it works. Whew. Thanks, Scott. Okay? Any other questions? Okay, I want to look at a couple questions. How am I doing on time? 17. Okay. I want to look at 47 with you, and I'm going to do one with you, and then I'm going to have you try one out. We had 47 on homework? Right? Okay, and it asks here, it goes, hey, when does this work and when does this not work? What p-value makes this work? Okay. I'm curious, especially after one of the questions that we just did. A lot of times on these problems, you always want to make p 1 first and see if that works, and then you want to make p anything else that's not 1. If I said p was 1, what type of integral, can you do this integral if I change it to an integral? This is just like that ln of x over x. Is this a perfect fit if you do integration right here? If I decided to do 2 to infinity oops. Can you do that one really quickly? You guys agree? Because is it a perfect fit? So this is really the integral of 1 over u. Notice the u's on bottom. Now, who is your u that you chose? ln of x, and the derivative of ln of x is 1 over x, so is it a perfect fit? So then this would be ln of u, which is ln of x from 2 to infinity. What happens? Diverges. What's ln of infinity? Blow up. So what's ln of a blow up already? Blow up? Blow up. So this diverges. So can p be 1? No. If p's 1, that integral blows up, so it won't work. So now I'm going to look at p not being 1. So let's see what happens here. I'm going to do the integral test, but what's p this time? Not 1. So when I do this, look at how I solve this one. It's still a perfect fit. Everything's the same with the u sub part. But this time, instead of it not being 1, it's actual exponent. Are you okay if that's how you would integrate that? You'd raise it to add 1 to the exponent and divide by that. You guys okay with that? Because again, the one that we had just done, just right above, was if p was 1, do you agree that would be u to the negative 1, which is 1 over u, which is the ln stuff? But if p is not 1, there's no more ln stuff. It's add 1 and divide. Okay, so now I need to look at this part here. I integrated. So I have ln of x to all of this from 2 to the infinity. Do you agree when you do ln of x, when it's at infinity, that whole thing goes to infinity, which is bad. Do you agree? Unless what? Yeah, if this is up top, do you agree it blows up? But if I'm somehow able to throw that infinity down below, now I'm talking about a number over infinity, which takes me to where? 0. So this is okay as long as I get this whole thing down below. So need the infinity in the basement. The only way to pull that into the basement is if that exponent is negative, the whole exponent. You guys agree? So I need the whole exponent to be less than 0, which means p needs to be greater than 1. You guys okay with on that thought process? As long as p is greater than 1, that infinity is going to be pulled down to the bottom. It won't blow up. It will converge to 0, which means the integral and the series converge. You guys okay with that? So I want you on the boards to try out that problem and this problem. And I'm going to write them on the same page so you can see, and then you guys can try them out. Okay? So you can go to the boards. Perfect timing for me to